Okay, so we're going to be talking about Unit 6C, which is adding and subtracting rational expressions. Some things quick to remember about adding and subtracting rational fractions from the past. When you're adding fractions, the thing that you need to do to add fractions, you need to get like denominators. So what you're going to be doing is each individual term you're going to be multiplying by a unique number to get that fraction where the denominators are equivalent. So going blast from the past, 1/4 plus 2/3, what's the common denominator? So usually you try to get the least common denominator. It's not necessary, but a common denominator here would be 12. Now sometimes a common denominator is used, a lot of times you just multiply the denominators together. It's not always the easiest way, but it always works. So I multiply something is equivalent to 1. 3 divided by 3 is equivalent to 1, so 3 times 1 is 3. 3 times 4 in the denominator is 12ths. So 1/4 is equivalent to 3/12. And 2/3, I would multiply that by 4 over 4, which then will give me 8/12. And when we add fractions, you add the numerators, and the denominators just come along. So this would be 11/12. Well, that was back in the day in middle school. Now let's get to something a little bit more high school level, adding fractions with variables. So again, you have to keep these same rules in mind. So we have to look at what's our common denominator between 4 and x. And the easiest common denominator would be 4x. So what I have to do to this first fraction to get it to be the denominator 4x, so I have to multiply by x. And so we multiply the numerator by x too, so x divided by x, that's 1. So we're multiplying this term by something that's equivalent to 1, which doesn't change the value of it. Let's look at what we have to multiply the second fraction by. Denominator is x, we want it to become 4x, so 4 over 4. So the first fraction becomes x over 4x, and the second fraction becomes 12 over 4x. You may think, well, I got x and x here, I can cancel those out. Don't do that, because then you're going to go back to the original problem. So we worked hard on getting the like denominators, so keep them. So now when we adding the numerator, what you're doing is you're combining to make one fraction. X plus 12, they're not like terms, so we just write it x plus 12, and that's over 4x. And you looked again to see if you can simplify anything, and you cannot. So getting into problems that you're going to be facing in Algebra 2 Trig, we have a fraction, a rational fraction, 4x over x plus 1, and we're going to add that to 4x over x plus minus 3. So x plus 1 is 1 is the whole denominator, so we're not going to look at splitting it up at all. I guess if you can factor it, you can do it, but in this case, this is a binomial and there's no greatest common factor. It's not no quadratic, so we can't factor this at all. That's what I'm getting at. Let's look at how can we get like denominators here. Well, the only way to physically get a like denominator is to just take the second denominator, multiply the first fraction by the denominator of the second one. This will give us x minus 3, and then x plus 1 as our denominators. And over on the second fraction, let's multiply by the first fraction's denominator. This will give us like denominators. So we have, in the first fraction, you have 4x times x minus 3 over x minus 3, x plus 1. Now we're adding it to 4x times x plus 1 over x minus 3 times x plus 1. So now we have like denominators. Awesome. Let's look at combining our numerators. So I'm going to first distribute. So I have 4x squared minus 12x over x minus 3, x plus 1, plus 4x squared plus 4x over x minus 3, x plus 1. Plus 1. So now we have like denominators, we have our numerators distributed out. Let's combine like terms. So we have 4x squared plus 4x squared is 8x squared. Minus 12x plus 4x is a negative 8x. And that's going to be over x minus 3, x plus 1. After you get them combined into one, so hopefully you can follow this. Oh, once you get it combined into one fraction, now we're going to look at factoring the numerator. Factor of the numerator I see is the greatest common factor of 8x. And we're left with x minus 1. And the denominator of x minus 3, x plus 1. So now I look to see if I can simplify the numerator and denominator, and unfortunately I cannot. X minus 1, x plus 1, they're not the same. They're not the opposite, so I can't divide by negative 1. So we just got to move on. That's our final answer there. Moving on to number 2, simplify the expression. So if you can factor a denominator, do it. So I'm going to factor this denominator. So first denominator, x plus 10, it's a binomial, no greatest common factor, not a perfect square binomial, so I can't factor that. But the second one I can. And we factor this into y plus 10 and y plus 2. And one reason why we factor is because then we can actually see what's in common if there is something in common with the other fraction. And we can see that, oh, we already have a y plus 10 in common. So we're looking for common denominators. So we don't have to do anything with the y plus 10s. They're already in common with both fractions. Now, we have a y plus 2 on the fraction on the right, but on the left we do not. So we have to multiply the first fraction by y plus 2 over y plus 2. And again, why we do this on numerator and denominator? Y plus 2 divided by y plus 2 is 1. And you multiply by 1, it does not change the value of the thing you are multiplying by. So, looking at this now, we have like denominators. I'm actually going to skip a step that I did before, but I'm going to distribute the 5. So it's 5y plus 10 over y plus 2 times y plus 10 plus 4y over the exact same denominator, y plus 2, y plus 10. And now, and you could probably skip this step too, but combining your like terms, you have 9y on the numerator plus 10 over the denominator, y plus 2 times y plus 10. Look to factor the numerator, nothing to factor, no 9y plus 10, the whole numerator, there's no denominator that's exactly like it, so there's nothing to simplify. And now we have our final answer. Last problem. So we looked very first to see if we have like denominators. We don't. Then we look to see if we can factor the denominators. 5x minus 30, you should be saying, yeah, you can take the greatest common factor of 5 out. So we put it out front. X minus 6. So awesome. We have x minus 6 and x minus 6 already is in common with both fractions. The thing that's not in common is the first fraction has a multiply by 5, the second fraction does not. So let's multiply the second fraction times 5. By doing that, we have a new problem. Starts out 2x plus 3 over 5 times. I usually choose to do the factored form of the denominator. And then I'm going to distribute in this 5 to the fraction. So that's 15x plus 20 over 5 times x minus 6. 2x minus 15x is a negative 13x, and 3 minus 20 is a negative 17. And that's over 5 times x minus 3, or x minus 6. The numerator, you can factor out a negative 1 if you'd like. There's no negative in the denominator, that will cancel that out, so that's not going to work. There's nothing else to factor, so this is your final answer. Come to class with any questions you have. Thanks, and have a good weekend.